All right, everyone. Welcome to our section for CS76. My name is Tommy, and today we're going to be going over iOS's core graphics and core animation. So whereby, so far in the class, we've seen some kind of higher-level APIs and mostly things in Objective-C. Today we'll be looking at some more lower-level nitty-gritty details, whereby we're actually using C APIs, kind of combining Objective-C and C. So here's our agenda for today. We'll first cover what core graphics is, how we can draw simple images and gradients and shadows. Then we'll take a look at working with images via various Objective-C classes there, how to animate things on the screen, both implicitly and explicitly. And finally, just as a little bit of a tangent, how you can integrate your app with other apps on the device, whereby other apps can call your app or your app can integrate with other apps. So both directions there. So the engine that we'll be looking at today is called Quartz. And this is what iOS calls their 2D drawing engine. So you might have also heard of something called OpenGL, which is a little bit different and a more general library. But iOS in particular is called Quartz, and that's what we'll be looking at today. And so the basic idea of Quartz is that we can paint multiple layers on some canvas. So we can draw objects on top of each other or behind each other. And the basic premise we'll be working under today is that objects are drawn in the order that they appear. So that's a pretty simple concept. So the most fundamental unit that we'll be drawing everything to is called the context. So this type is called the CG context ref. So pretty much everything that we'll take a look at in the core graphics domain is going to start with CG for core graphics. So again, this is a deviation from NS for next step. We also saw previously MapKit, which started with MK. So if in the documentation you see anywhere something like CG, it's something that's going to be core graphics. And so you'll notice here that the way in which we retrieve the context, which is basically what we're drawing to, is via this method here. Still has a huge name, UI graphics get current context. But you notice that this is no longer an Objective-C message. In fact, this is just a standard C function. And so this kind of shows how Objective-C and C are intertwined, where Objective-C is just a set of features on top of C, but that doesn't mean that you still can't use C in addition. So the type of a lot of the objects we'll be looking at today, including this context ref, is just going to be a standard C struct, or a pointer to a struct. So no longer are we looking at Objective-C objects that are alloc and initted. We're just dealing with standard C constructs like structs. So the Objective-C big message of the day here, or method of the day, is this method called drawRect. So this is the method that's going to be called on any UI view that's going to actually draw what that view is. So when you've put a UI button onto your nib, and iOS loads up your app, it needs to draw that button. What it's going to do is it's going to say, OK, well, this UI button is an instance or a subclass of the UI view class. So the first thing I'm going to do is send this message called drawRect, and that's going to actually draw the button to the screen. So this is something that we've just been taking for granted so far. We put a button on the screen, and there it is. Whereby today we're actually going to look at how that button is actually drawn. So the first thing we'll need to learn about are paths. So a path is just simply a set of points that you can connect in different kinds of ways. So again, the basic data structure for paths are CG mutable path. Again, this is just a standard C struct. You can create them via not with something like alloc init, but with the C method CG path create mutable. That's going to return to you a similarly named object because it's mutable, which means we can change it. But again, we're not really dealing with Objective-C objects anymore. This is standard C. So the two basic concepts in a path are a point, which will define all the points that can be connected by a line or a curve, and then the line itself. So a line we're just going to be defining as a series of endpoints. So in this case, using either an NS array or a standard C array that will define some points that are, again, just structs in the order that they appear. So in order to move around our little pointer, so you can imagine basically since we're drawing on a canvas, we basically have a pen or a pencil in our hand. And we can do two things with that pen or the pencil. We can connect dots, or we can pick it up and move it somewhere else. So if we want to pick up our pen from the screen, we're going to use this function called CGPathMoveToPoint. That's going to say I want the current drawing point to go to some coordinate on the screen. Or if we want to move our pen around, keeping the pen down and actually drawing to the screen, then we're going to use this method CGPathAddLine2Point. And that's ostensibly going to add whatever point you supply to the current series of points that you're connecting to form a line or something else. So lines are kind of boring, so we can also do things like create different kinds of curves. So if you're into the math behind Bezier curves, which is actually kind of crazy, if we pull up the Wikipedia article on Bezier curves, it's actually really cool. Wiki meant to load this up beforehand. But basically what this Bezier curve is something that looks like this. And we have some nice animations. But basically by defining these control points, you can kind of create an arc that is very mathematically defined. And these mathematics are way above my head because they have crazy things like that. But basically know that these are how you can do more than just draw straight lines. Rather than having to define all of the points that compose this curve, iOS has built in this really rich API for defining these curves. So feel free to do more research on what those are, but they're really cool. So this is your basic workflow for drawing a path on the screen. So once you've defined your set of points, as by saying I want to move to this point or I want to add this point to the current line, at some point you're going to be finished with your drawing. And at that point, you want to call this method cgPathClose the subpath. So that says anything I add after this, I want to create a new shape or create a new path. So then once your path is complete and it's stored inside of that object that we called the mutable path ref, which was just a C struct or a pointer to, then at some point we want to add it to the current context. Remember, the context is just what we're drawing to. And everything today that we're going to be looking at, we're just going to be drawing to the screen. So when we say context, you can just consider that that's the screen. So then we can do two things to this path. We can, one, make a line out of it. Or so basically, that's the second function here, the stroke path, which will draw a line or a curve connecting those points. Or we can fill it in. So like the Photoshop paint bucket tool, if I've created a square, and rather than drawing the outline of a square, I want to fill it in, then I'll use this first method here. So then we just have some other options that we can apply to our lines. We can change the weight of the line or the width of the line. We can say if we want to end on a little dot, or if it wants to be a more rectangular ending, you can make it dashed, et cetera, et cetera, et cetera. But notice that all of these methods here, again, they're just standard C function calls. There's no fancy Objective-C here. So let's just take a look at an example of what I mean with all of these points. So you notice here that my app, I just used the standard single view application here. So I just have a view controller and a nib. But you'll notice here that my viewcontroller.m file, I haven't modified at all. In fact, it's not really doing anything. It's simply loading the view, and that's it. But if we take a look at my nib, you'll notice here that there's something different. So normally, this would just say view. And this is something that we haven't really touched in the past. But in this case here, mine says path view. And if you click it and come over here to the properties inspector, or if I click it and come over here, you'll see here that I've changed the class from the generic UI view, which is given to me by the template and that we've seen so far, to this class called pathsView. And this is a class that I've defined myself. So after I've changed the class of the view, and therefore changed the text over here, this is the class that I've created. So if we look at this .h file, you'll see here that no longer am I extending NSObject or UI view controller. I'm actually just extending a generic view. So this view, again, is not going to be a controller. It's not going to interact with any models. It's not going to perform any something like game logic or anything like that. This is simply a class that's going to define how the view is drawn. So if we look at this implementation file, you'll see here that this initWithFrame is just the kind of generic constructor method for creating a UI view. So if I wanted to, I could either overload this as by creating a new initWithFrame and something else and something else. But in this case, I'm not really doing anything fancy, just calling the super method. And now here, remember, this was the message that we cared about. So this drawRect is going to define how this view is drawn. So it will be called once. And if you want to draw it again, you can use that method called setNeedsDisplay. That will basically say to the view, I want to call drawRect again and clear what you drew beforehand and draw whatever drawRect spits out. So let's just walk through this. The first thing we need to do is determine what we're going to draw to. So this is just going to be the screen in the case of any iOS device. So we're just going to use this incantation UI graphics get current context. And that basically gives you back where you're drawing to. So now we're going to do two things. We're going to draw a line and we're going to draw a rectangle. So you see here that both these shapes, my line and my rectangle, are defined in terms of this mutable path, which again is just a collection of points. So here I'm going to create a line here defined in terms of 2 points. So my first point is at 1010, so the top left corner, and my second point is at 310, and so this will be around the top right corner. So you see here that I've first moved to this first point, so I've picked my pen up and I've stuck it at that first point. Then when I say add line to point, I'm basically tracing my pen across and adding that new point to the path, and then I'm closing the subpath. So that means that I finished off that one shape, and that one shape is now stored within line path. And the way I'm doing that is by passing line path to each of these methods. So as each of these lines is called, I'm effectively mutating or modifying what this path looks like. So then we're going to do basically the same thing for the rectangle. I'm just defining it in terms of its 4 corners. Again, we'll close the subpath. And so now, this is where I'm actually performing my drawing. So the first thing I'm doing is I'm just arbitrarily setting a line width, because I want my lines to be thicker than they usually are. And then I'm going to add both my line and my rectangle to the current context. So that is what's actually going to draw them to the screen. And so I'm saying I want this first one to be a stroke, which means I just want a line connecting them. And I want the second one to be a fill, which means I want the area enclosed by the points that I've defined to be filled in with some color. And you notice here that I'm just specifying as the second argument here what color I want to be filled in with. So here is my drawn black line and my drawn red rectangle. Any questions there? So another part I just quickly glossed over. So Objective-C has within it this nice class called UI color. So if you want to retrieve really common colors, rather than having to define the RGB values yourself, which can get kind of annoying, you can actually just pass these nice convenience methods to the class itself. So if you want red, I can say red color or blue color or gray color. And so that's going to give me back an Objective-C object. But remember, with core graphics, we're not dealing with Objective-C objects. We're dealing with purely C structs and whatnot. So to convert this Objective-C object representing a color to the appropriate core graphics representation of a color, it's really easy. I can just say .cgcolor, and that's going to give me what core graphics is looking for. That's going to be a pretty common design paradigm here. Every time that you see something in Objective-C that needs to be in its C form, just say .cg whatever, and you'll get what you need. So that's drawing basic shapes. So 2 cool things we can do with core graphics are shadows and gradients. So first, we're going to define a shadow, much like we do in CSS. We can say it has an X and a Y offset from the element that it is shadowing. And then we can also define a blur, which is basically the size of the shadow. So one other thing that is helpful in core graphics is this idea of saving state. So you notice here that when we change the state of our graphics context, so here you notice things like setting the line width and changing the color. You notice how this is affecting basically everything that is drawn after I make this call. So it could be the case that when I want to draw this rectangle, I have to set a whole bunch of options pertaining to that rectangle. Now let's say I want to draw something else. That means hypothetically I would have to set a whole bunch of options pertaining to that something else, but then if I wanted to jump back, I'd have to set a whole bunch of options, and that can be really annoying. So what iOS does for you is it allows you to basically save the current state of the world as it is and later return to it. So it's just like our UI navigation controllers where we're drilling down into more information. We can do the same thing with the current graphics context. We can say, I want the current state of the world to be pushed onto the stack. And if I later want to return to it, I can pop from the stack and get those options reapplied to the context. So let's take an example. Let's take a look at an example of that. This is the one I didn't open. OK, so again, same setup. The first thing I've done is I've changed the class of the view controller's view to be a custom class that I wrote myself. Again, we have to make sure we're extending UI view here, because we're not a view controller. We're just a view. So now, if you look at our implementation file, you'll see here that we're starting off much of the same way. We're going to get the current context. And the first thing I'm going to do is I want to take this kind of blank slate and push it onto my stack of states. So this push G state or save global state means that the current context has no options applied to it. So just as it was when I first created it. So I'm going to draw 2 things. My first triangle here, I'm just going to draw it much in the same way we drew the other shapes, just defining 3 points, making sure to say add line to point when we want to connect dots. So we'll close that subpath. And so now we're going to say, I want to apply a shadow here. And that's my bounds of the shadow and also the blur of the shadow. And again, these are just in terms of pixels. And so now I want to draw another triangle. But this other triangle, I don't want to have a shadow attached to it. So hypothetically, I could say something like, I want to, instead of, I could change the shadow color to basically say I want there to be no blur and I want it to be nowhere, which will mean that there's no shadow on the other triangle. But because we've conveniently saved the state of the world in which no shadows were applied to anything, I can simply jump back there by saying restore global state, which will push a value off the stack, which means that those shadow options that I applied to my last shape there will not be applied when I call draw down here. So what we should get is one triangle that has a shadow, and then a second triangle that no longer has a shadow because I've reset the state. Make sense? So again, one thing to remember with this core graphics stuff is that every time you add an option, you're adding it to the context itself. And so everything that is subsequently drawn will have those options applied. So just because I've said set shadow, that doesn't mean that the shadow will only apply to the next thing I draw. It's going to keep applying to things until I tell iOS explicitly, OK, I don't want you to do that anymore. And the way in which we do that is very commonly just restoring to some state in which that option is no longer applied. So that's shadows. So core graphics can also nicely draw things like gradients. So predictably, we're going to be working with these structs called gradient refs. So we can draw two types of gradients. We can draw an axial gradient, which means we're just going to define a line, and we're going to vary the color along that line. But we could also do what's called a radial gradient, and basically draw concentric circles, so circles around each other, with each outer circle kind of moving from one color towards another color. So to draw a gradient, we need to start dealing with different types of color spaces. So the color space that we're all most familiar with is the RGB color space, which will define a color as a combination of red, green, and blue. But know that iOS also supports color spaces like CMYK, which is very common if you've ever done print media, because that's how a lot of printers want things, or even something like grayscale. So all of these gradients are going to require one of these color spaces to be defined, but gradients are drawn very simply. So again, we're starting off by just getting the context, something that we need to do first. And so now we're going to, rather than using NS arrays or NS dictionaries or anything that looks kind of organized, we're instead going to be using standard C arrays. So this gets kind of confusing, but we're saying the locations of my gradient, I want to vary it from basically from 0 to 1. So all of one color to all of another color. And so now we're going to define 8 things here. So the first 4 here are going to be the red, green, blue, and alpha of the first color in my gradient. And the second half here, which is also 4 things, is going to be the red, green, blue, and alpha of the color that I'm moving to. So see here that I'm basically moving from red, so turned up all my red, turned down everything else, to my green. Only the green is turned up all the way. So notice here what can be kind of annoying is in CSS, these are often defined in terms of 0 to 255. Whereby iOS instead is going to define things in terms of 0 and 1. So it's not uncommon in graphics code to basically see, rather than 0.566 or something like that, but 200 divided by 255.0. And just work with the colors that your designer gave you rather than trying to have to do all of the math yourself. So here's where we're actually going to create my gradient. And these method names are getting longer and longer. But we're taking all of these things we've just set up, basically the colors that we're going to and from and how we're varying between them, and we're just creating this gradient object out of it. And this last method here is necessary because of a basic limitation in C, whereby you cannot simply determine the length of an array. It's just not something you do in C. So in order to tell iOS how many elements are inside of my gradient, in this case just 2, I need to explicitly say, when you draw the gradient, expect 2 things inside of here. There's just no way for the C code to determine how many that you need. So here we're just going to take this same gradient object, and we're going to represent it 2 different ways. So I can draw it linearly here. And again, here's the starting point of the gradient and the ending point of the gradient. or we can draw it radially. So this is that circles thing. So again, we just have a starting point, an ending point, and a radius. So if we draw this, we can soon learn how quickly and easily we can create hideous things inside of iOS. And so here are my two different types of gradients. So I'm fading from all the way to red to all the way to green. And here's my linear gradient here. And here is my radial gradient. So questions on how we can draw those? OK, so now let's look at some actual applications of these drawing things, now that we're comfortable with drawing basic shapes to the screen. So we've seen here that we can basically create our own UI views now. And remember that all of the controls that we've looked at so far are simply UI views, be they buttons or toggle switches or whatever you want to call them. And this drawRect method is a method of any UI view. So it's not something that's specific to a button or anything custom that I'm going to create. So that means that if I want to create my own button, my own table view cell, all I need to do is extend the appropriate view and then use it. So let's do just that. So first, let's take a look at how I can create my own button. So rather than creating this arbitrary view, I've now defined a class that I've called custom button. And again, now instead of simply extending UI view, I'm free to extend UI button, which itself is just extending UI view. So that means that I have all those methods that we've been talking about. So this is the standard constructor for a UI button. It expects a frame that defines how big the button is. It expects a title, so what text will be displayed in the button, and it expects the color for that text. So I haven't really done anything fancy with this constructor. I'm just basically saying whatever the user passed into me, I want to set those via these methods here, set title and set title color, that are defined by the UI button class. So now here in drawRect, this is where we're actually going to draw the button to the screen. So we're back to using gradients again. So I'm getting the screen to draw to. I have that same gradient that I used before. I'm varying between red and green. And after I've created this gradient, here is where I'm actually drawing it to the screen. So this is the same thing that I did before, but notice that rather than defining things in terms of arbitrary points, I'm defining them in terms of what the user told me. So up here, the user passed in this frame, and the frame effectively defined where the button was on the screen and how big it was. So when I actually draw this gradient, I want to say that I'm going to start it at where the origin of the button is, so that top left corner, and the area that I want it to cover is defined by the size of the button. So this is where I'm actually drawing the button to the screen. So I've said that I want to start in the top left, and I want to go some defined width and height that are defined by the user when they create this button, and I just want to draw this gradient to the screen. So now this gradient is effectively going to serve as the background of my button. So now, when I create my button, I'm not really doing anything fancy. If instead of saying custom button here, I said UI button, this would still work. So I've just basically replaced any call to UI button with a call to my own custom button. So I can assign event handlers in the same exact ways that I would to a regular UI button. Whenever I fire the event touch up inside, I want to fire the selector called pressed, which is just going to trigger an alert view. So here is where you can really impress your friends with a lack of design knowledge, because you can create buttons that look like that. So I really wish I had any semblance of artistic ability. But when I press on this, it's going to interact just like any other button would. And so you notice that I didn't let iOS draw their admittedly nicer button for me, but I've just drawn a gradient, and that is how my button is now going to be represented on the screen. This blue text here was something that the user defined for me. And remember, when I called that method initWithFrame, I just said I want the text to be whatever the user told me. Any questions there? OK, so let's get a little fancier now and define our own table view cells. So we saw before that we could, if we wanted to define our own table view cell, we could create our own nib. And that nib would extend a UI table, or be of type UI table view cell. And then we had this way using the bundle of loading the nib into memory and then assigning it instead of the normal Right, so basically, we'd assign it to this cell here. So we'd load the nib into memory, and we'd say, I want this cell that was just loaded into memory to be an instance of this nib. So if we really want to have full control over what our table cells look like, we can actually simply define our own custom cell objects. So again, these are just a generic UI view, so I'm just extending that. And so here, this is the actual drawing of my individual cell. So just everything on screen here. This is the drawing of my individual cell. So rather than loading a nib into memory or working with nibs at all, I'm literally defining it right here in my code. So because that button was so horrendous, I'm not going to try to do anything fancy here. I'm just simply going to draw a red rectangle. So I first define my color to say I just want everything to be red. And now I'm going to draw it in terms of the bounds that the user specified. In this case, the user isn't really specifying bounds. iOS is saying the table view is going to fill whatever area it fills on the nib. So here, I'm created my own table view cell, but not with a nib. I'm defining how it looks like in Objective-C code. And to do that again, I'm not really doing anything particularly different. What I'm doing is after loading the standard cell, which is going to define where the labels are on the cell, because you notice that I'm only drawing the background. I haven't touched anything with the text that's displayed in the cell. So now I can set the view that defines the background to that text via this property called background view. So you notice that my custom cell was an instance of a UI view. So I'm not really creating a cell. I'm simply creating a background to a cell. So that means that I can set what I've created to be the background of each cell by just instantiating a new instance of my cell view. So not a cell itself. This is simply a view to be applied to a cell. So one thing to notice, without this line here, my view would not appear to display at all. And that's because by default, the background for the text label is going to be white. And so because the text is drawn on top of the background, the white background of the text would cover up my red background. So I just need to say this to say that I don't want any background to my text. I want it to be transparent. So if I run this, we just see something very simple whereby I have a bunch of cells with red backgrounds. And again, I'm not using a nib at all. I've defined this user interface entirely in Objective-C code. So any questions with creating these custom components? OK. So let's move on from drawing shapes to working with actual images. So the fundamental object representing an image in Objective-C is going to be called the UI image, which looks a little awkward with these two I's repeated. But an image can basically take an image that you have inside of your bundle or data from online and represent it in memory. So this is much like the bitmap object with which you became familiar in the Android N puzzle. So what will actually display the UI image is going to be the UI image view. So same parallels to Android. We had image views that could display bitmaps. In iOS, we have UI image views that can display UI images. So let's say now, instead of putting an image on disk that you want to just display to the user, you want to display something that the user saved on their camera. So starting to integrate with other apps here. So we have this nice view controller that is already written for us called the UI image picker controller. And this has some really, really handy controls for allowing the user to select an image from disk. So you're going to basically simply instantiate this view controller, much like you've instantiated any other view controller that you've written. And then you can display it to the user modally, so sliding up from the top or however else you want to display it. It will allow the user to browse their file system or their camera roll or take a picture and save it and then load it into your app. And all that functionality is given to you automatically. So much like a lot of iOS's core APIs, this makes heavy usage of the delegate design pattern. So make sure that when you create this view controller, you make sure to set the delegate properly. Now here are just a couple delegate methods you might care about. When the user actually selected an image, you get a callback that's saying what the image the user selected was. Or if the user wanted to cancel the image, cancel instead of actually selecting an image. So if we load this up here, you'll see that I have a nib here. I have a UI image view, and this is what's actually going to display an image. Then I just have a button that will pull up that image selection view controller. So here is my instance of this view controller. I've just loaded it as a property of the class here. I'm saying that I want, by default, I want the user to be able to select from the photos that they've saved onto their device. And what's really cool is I can even allow the user to resize or crop the image after they've selected it before it's added to my app. So to allow the user to start working with the images on their device, all I have to say is present this picker to the user. And then everything will be handled for me. And this is the callback that I really care about. And this is fired when the user actually selected something. So you'll see here that I'm getting passed back an NS dictionary, which means I have some key value pairs, one of which is going to be a value defining what image the user selected. And so the key for that value is just defined by this constant here, this image picker control whatever. This is just basically indexing into that dictionary and pulling out the image and displaying it on the image view. So if we run this, OK, so now if I click Choose Image, I'm going to get here a nice browser of everything on my device. So I've just saved here an XKCD comic. If I select this, you can see here that I can move around the image, I can scale it, and I can do all these really fancy things without having to implement any editing controls myself. So now when I click Choose, it's going to give me back the scaled image that's been moved around as I want, and I can then display that as simply a UI image. So any questions on how that process worked? All right. So we could just simply display this UI image using this UI image view, and that's all nice because the user can look at what the image is. But we can also take this UI image and convert it to a core graphics image and start using some of these things we just looked at in core graphics and applying them to images. So remember that we had this method called drawRect for a UI view. Kind of the analogous method for the UI image is the drawInRect, which says that I have some image in memory, and I want to display it on the device at this point in the screen. So I can scale the image here, and things like aspect ratio preservation are taken care of. So sorry about making you do that for Android. And then we can also use this lower level method, the CG context draw image, to really control, use core graphics controls on the image. So we can do cool things like transform the image. We can rotate it. We can scale it and translate it. And each of these transformations, much like in CSS, will be determined and will be defined in terms of a transformation matrix. So we can also crop the image ourselves, basically by saying, I want to define a path in which the image will be displayed. So rather than just draw the whole image or draw the image as a rectangle, I can draw the image inside of any container I want. So a triangle or whatever shape that I can define with this same path. So let's take a look at that. So first, let me do this so you can fully absorb this image in all of its glory. So I have here an image that was supplied to me by a good friend of mine, and it happens to be David's college yearbook photo. And so this is David back in the day as an app. This is well worth 99 cents for anyone, I think. So the way I've done this is I simply have this image on my computer, mailin.ping, and I've dragged it from my Finder window into supporting files. So if I click this, I can again see this because this will never get old. And so to load that from disk, all I need to say is UI image, and then I just supply the name of the image inside of that supporting files folder, and iOS loads it into memory for me. So then to actually just draw that image using Objective-C, no fancy core graphic stuff, I can just say drawInRect, and this rect here, you notice this rect parameter was given to me by the drawRect method. And that's because, again, I'm using the same technique. I've replaced the default view with this view called photo view. And so that means that this supplied rect here, this rect parameter, just represents the entire screen. And so that's why when I said drawInRect, I have actually just drawn the entirety of the image to the screen. So now let's say I have another image, like this mustache, that I want to draw to the screen. So if we simply did this, so let's leave that out. So again, we're going to load. Need this. OK. And that didn't do anything. There we go. So again, I'm going to load this image onto memory in the same way. The fact that it's a JPEG doesn't change anything. So I'm loading this into its own UI image. And so now, rather than using the Objective-C method, the draw in rect, I'm instead going to use the corresponding core graphics function now. So I'm going to send that same context thing. And so now here is where I'm going to define the bounds for my image. So this is just going to be displayed right now in a rectangle. So there's the top left corner of the rectangle, and there's the width and height. And so finally, to convert this UI image to a core graphics image, all I need to say is .cg image. And that's going to give back something that core graphics can work with. So now if I run this, you'll see that I've drawn the mustache on top of David. But you'll notice here that in this case, I have some ugly white around this that I kind of want to get rid of. So to do that, let me pull that back up. I can basically define a path to define new boundaries for that image. So rather than drawing the entire rectangle, let's say that I kind of want to draw a shape here where I cut this section off and I cut this section off. So all we need to do is define a path that does just that. So if we come back up here, and we'll uncomment out my path, you'll see here that I'm just creating a path, and I basically define those points. I start in the top left, then I move down to the bottom left, and then I kind of create that line to the middle of the mustache. So I cut off that white on the bottom left, and then I go back down, cut off that. And now I'm going to add the path to the context. But in this case, I don't want to draw anything along that path or fill that path in with any color. Instead, what I want to do is say anything that is going to be drawn to the canvas should fit within that path. So I do that by saying the CG context clip. This says any subsequent draw calls, remind you, core graphics calls now. So if I were to say draw in rect, that's not going to apply. So any core graphics calls that I'm about to make have to fit within the path that I've just defined. So that means that when I later draw this mustache, even though its bounds are defined in terms of a rectangle, because I've defined this more specific path, when this is drawn, it's going to look something like that, whereby I've clipped the bounds in which this is drawn to create a much better app, raising my revenue significantly. So yes, in this case, you really should have simply replaced the white with transparency, but now you know all about clips and paths. So any questions on how those two things interacted? So I hope to see lots of David apps. The image will be available if necessary. So now we've worked on drawing static images. Let's take a look at animations, so how to make things move around. So in iOS, there are basically two ways to animate something. And in both ways, all you're really doing is animating these 2D layers inside of 3D space, which sounds boring, but actually creates some really cool looking effects without trying that hard. So there are two ways of doing this in iOS. So the first is called an implicit animation, which you say, OK, I'm going to start an animation. I'm going to change a bunch of properties in the object, like its size or its color. Then I'm going to say, everything that I just changed since I said start, I want you to animate. So that's kind of a nicer, simpler way of doing it. If you really want to control how things are animating, you're going to use explicit animations. So let's look at both. So to use any of these animations, you're going to first need to add this Quartz core.framework to your project. And this is super easy to forget. But if we pull up one of our animation examples, here we go. So you notice here that if I've come, or not this one, the other one. So if I click on my project properties here, so I click here on my project, I come over here to build phases. You notice here that I have to click on this plus, then I can start typing in Quartz, or if I actually type, then I just have to double click on here, and this will add the framework file to my project. So we saw this before with MapKit. So now this .framework file should appear here and here. And you're free to move that around into the frameworks folder if you want to make things more organized. So then, only once that framework has been added to your project so that your project can link to it, you now need to import the corresponding header file so that the compiler knows what methods are defined in this static library. So make sure to add import Quartz core, and then for this animation stuff, we'll be just simply using this one header file, CA animation, that will take care of loading everything else that's necessary. So implicit animations, as we said before, are just static methods to the UI view that says I'm going to make some changes to properties, and once I'm done making all those changes, I want you to animate them. So that means that I could change the position or the size, and that's going to move smoothly for me. Or I can even do things like change the color. And again, the iOS handles what it means to animate between these two things. So here are some methods to kind of customize what they look like. You can, much like in CSS, we have these nice stock animations built in, like starting off fast and slowing down and then speeding up again, or the vice versa. All those are defined in iOS for me, and those are called animation transitions. So more straightforward, I can say how long I want this animation to last, and that's going to be the duration in seconds. And finally, if I use the animation delegate, I can have access to these nice callback methods that say to me when iOS actually finished doing something, or when it was stopped for some reason. So if we jump back to the implicit example. OK. So here, rather than drawing my own core graphic stuff, we're back to working with simple Objective-C UI views. So I have here two buttons. If I press this button, I'm going to trigger an animation. If I trigger the other button, press the other button, I'm going to trigger a different animation. So both of these buttons are connected to this IB action that I've called button pressed. And I've defined this method in my .h file. I've connected it in the nib. So this is when it's going to get fired when either of these buttons are pressed. So the first thing I'm going to do here is I'm going to define a new animation block and say to iOS, anything I change from here on out, I want you to animate. So because I could hypothetically have a bunch of blocks going on at once, I'm going to give each block an identifier. So this is going to say anything I change, add to this set of property changes inside of button, or identified by button. So these two buttons have different tags. So this first branch here, if the tag is 0, that means I press this top button. And you'll see here all of that I'm doing is I'm moving the button either up or down. So by changing this center, which is a CG point, or something you could add to a path, I'm either taking the center and moving it 300 pixels down or 300 pixels up. And by keeping track of the number of times you've pressed that button, that means it will alternate going up and down. So that's going to be a translation. So now down here, if I press the other button, we can do something a little cooler. So I have here this built-in transition, this transition curl up. And this is a nice animation that's already been defined for me. So I'm going to say that I want the animation to last 1 second. I am going to be the delegate for these animations. So any callbacks, I want you to pass to this view controller. And finally, I'm registering a callback. So I'm saying when you stop, I want you to fire this method that I've defined here. So what we're actually annotating in this case now is not the position, but the transparency. So by setting the alpha, which is just a CG float from 0 to 1, we're going to change how opaque the button is, depending on, so it'll first go to transparent, and then when you press it again, it will detransparentify. So there's where I've modified the properties to both of my objects. And so now when I say commit animations, I'm going to start all of my animations that I've defined. And so finally, this callback is super simple. I'm just going to display an alert view once my animation has finished, because that's what I said up here, set animation did stop. So this first button here, if I press it, you'll see here it's going to animate downwards. So if I didn't use animations, it would just kind of jump down. Or if I click it again, it will go back up. If I set the duration in this case, that will effectively change the speed with which this animates. So now if I press this other button, this is going to try to apply this animation, this page curl animation that you'll see when often the Maps app, when you press the bottom right corner and the page kind of comes up a little. So if we apply that to this button, we get this really crazy effect that looks something like that. And so there's my callback. The button has been done curling off of the device. If I click this again, it's really cool looking. And we're going to reanimate the opacity of the button there. So these were two animations that I really didn't have to do much to get. I simply said where I want this button to go. And iOS said, OK, I'm going to make sure that animation is smooth. You can change the speed without really doing anything super low level. So any questions on implicit animations? OK, so now let's take a look at explicit animations. Whoa, that's a cool feature. So whenever we have a UI view, it has corresponding to it several layers. And so these layers are what we're going to actually be animating inside of our core animations. So these animations, unlike implicit animations, are much more explicit, and they're borrowing a term from CSS called a keyframe animation. And so this says I can really define frame by frame what I want my animation to look like. So there's a list of properties that are animatable in this way. If you just click on this link, you can see how things are going to be animated. But one thing we can do here is basically define a path along which we want something to be animated. So in our last example, we were kind of limited because all we could do is really change the center. There was no way for me to say move left, then move down, then move right, because I could only change one property and then iOS would change that property. So if I want to do something like animate a button along a path or something like that, I would have to use an explicit animation. And again, the way we could define this path is just by the same object that we've been using all day, this CG mutable path ref that we use to define squares and draw a mustache on David. So we can also, inside of our animations, perform transformations. So if we want to animate a button scaling up or rotating, we can do that. And so if we open up the explicit animation, so we've been sure to add Quartz core. And later, we've imported the corresponding header file. So first, let's take a look at the nib. So again, we just have two buttons here that when pressed are going to fire the same selector. So here we go. So rather than simply implicitly animating things, I'm first going to define a path along which I want the button to move. So I want this path to start at the button's current center. So to do that, I'm just going to say this button 1, which I've defined as a property now, I can get the x and y coordinates as its center, very simply. And then here I'm just defining a path. It's going to go down, it's going to go left, then down, and then back up to the right. So now, from this path, I want to make an animation out of it. So I'm going to create a new CA keyframe animation object. And this is what's going to be used to handle these explicit animations. And again, much like we identified the set of things changing in our implicit animation, we're just going to give this some identifier. And in this case, rather than just serving as something arbitrary, this is what is going to actually be animated. So remember that list that I showed in the previous slide of all the properties that can be animated? This is where I got this arbitrary position thing from. This is telling iOS, I want you to animate the position. So again, we're using this identifier, but a little bit of a different function than it has in the implicit animation. So this animation needs to have a path along which to move. And so that's the path I created up here, this mutable path ref thing. So we're also going to specify a duration. So how long do we want this to last, which in turn is going to tell me how fast this is going to move. So I'm going to animate this property of the button called the layer. So this is the core animation layer, or what can actually be animated in the button. So it's very easy to forget the dot layer, but just remember that anytime you're animating something explicitly, you want to apply the animation to the layer, not to the UI view itself. So that's one animation. So the second animation is a little bit different, and this is going to define a series of transformations. So I have here a rotation, two rotations that will rotate it 90 degrees. Then I also have here a transformation. And so this is going to scale it up. So again, I'm going to first create a new keyframe animation. And rather than animating the position this time, I'm now using this property called transform, which I just looked at that list of properties and figured out that's what I needed to use if I wanted to change the shape. And so now, rather than specifying a path, I'm going to specify a series of values that I want to use as animation values. So again, these are defined in terms of transformation matrices. And so this says that by supplying these three matrices, they're going to be applied in the order that they appear. So I want, in total, this animation to last 2 seconds, which means I want to rotate it, scale it up. That's going to take 1 second, because I've also set this property here, auto reverses, which says that after I rotate, and scale, I then want to go backwards so that the button returns to its original state. So I'm going to then scale it back to its original size and then rotate it to what it was before. So now to actually start up the animation, I'm going to say the same thing. And using the transform key here, so now I run this. So this is a little more straightforward. I'm going to go that way, and that way. So each of these took an equal amount of time. And so on this one, I'm going to rotate, rotate, and scale. And now I'm going to reverse those things to go back to my original position. So questions there? So regarding the actual values of these transformation matrices, definitely check out some documentation for CSS transforms, just because that'll probably be a little bit easier to read than anything A, mathematical, or B for iOS, which is always some interesting opinions online about that. But it's really not too complicated where these numbers come from, and the CSS is probably your better resource for learning about this kind of image transformation stuff, if you don't already know it. So finally, let's just take a look at how our app can integrate with other apps. So just like in Android, we can open other apps via these special URLs. So to do that, I have this special singleton object called the shared application that's going to represent your application itself. So by telling your application to open a URL that starts with something like HTTP for a web browser, tel for the telephone, SMS for iMessage, or whatever it's called, that means that we can switch from our application to another application. So if instead you want to be able to be opened by another application, so integrate with the web browser or integrate with some other app that your friend wrote, we can use the iOS equivalent of Android's Android manifest.xml file, which basically defines some project level properties. So in iOS, this will be defined as a plist. So the first part of the plist will be your app's name. And then there's this method inside of your app delegate called application handle open URL that's going to be fired if some other app on your system is trying to open a URL that your app has registered to handle. So let's look at how we actually register to handle other apps opening us. So here's that plist file. So because I've called my project integration example, I have this file called integration example info.plist. So if I click on this, I've added here a new item to my plist. So this wasn't here before. I just came up here and click enter. And from the dropdown of all this other properties I can set in my project, I've selected URL types. And so this is going to be an array. And each item in this array is going to define a schema for a URL that your app can handle. So the first thing is going to say, give an identifier for your app. So this is much like we did in Android. This was just my app identifier that I set up here in my project properties. When I created the project, I just said I want to start with edu.harvard, and then it ends with the actual name of my application. And so this is just the equivalent of the Java package identifier, just something unique, some unique string that identifies my app. So then, we're going to define these URL schemes that we can open. So in this case, I've just defined one, and I've called it CS76. So that means if the web browser or any other app on the system tries to navigate to a URL that starts with CS76, so something like CS76:// and then something/something, that means that iOS should call my app and say, hey, the user just tried to open up one of these CS76 URLs. And because I've specified inside of this plist that I can handle this URL, that means that my app is going to be informed. So what's going to happen is this method here inside of my app delegate is going to be fired. This application handle open URL. And supplied to me is the actual URL that the user entered in, so I can start to pull information from there. So what my app is going to do is going to be able to be opened by another app, and the other app can specify what text they want to be displayed inside of my app. So to make that specification, or tell my app what to be displayed, I'm going to give it a URL that starts with CS76://, and everything after that part is going to be the text that will be displayed inside of my app. So here I'm just doing some basic URL parsing. I'm saying I only care about the part after CS76. I want to ignore the first two slashes, and I want to basically URL decode. So replace things like %20 with the actual space. So the opposite of encoding a URI, which you've probably done from JavaScript. And I'm just going to take that string and use it as the text to be displayed inside of that label. So I also, for my app, have a button here with which I can open up Safari. So when that button is pressed, this IB action here, which I defined, is going to get fired. So here's the singleton instance representing my application. And it is to this instance that I can say, I want you to open things. So I want you to open the URL google.com. So iOS is going to say, what applications have registered to open http://. In this case, it's probably just going to be Safari. If I said tell, then it would open up the phone for me. So I've just said that I want you to handle opening up this URL. And iOS will do so simply by flipping to the appropriate application. So let's run this. Hopefully. Interesting. I've crashed Xcode. No. All right, let's try without crashing Xcode. This will just be like another 2 minutes. I don't know why this crashed. Oh, come on. Come on. OK, there we go. So our app is now running. If I click on this button, you notice that it's going to flip open to the application that is appropriate for opening that URL. So now from the web browser, if we try to open a URL that starts not in HTTP, but in CS76 : hello, and I navigate to this URL, we're going to flip back to my application. And this other application has sent information to me, which I've then used to change this text. So any questions on how integrating with other apps worked or anything else we've covered today? All right, well then good luck. I'd love to see the apps that come out with your Student's Choice project.